So example 1, it says, what are the real cube roots of 125? And the word I want you to focus on here is real. Okay? There are imaginary roots all over the place for numbers. If you multiply certain numbers times themselves 3 times, you can get 125. But we want real numbers that do it. All right? So the basic idea of this problem is this. I want x to the 3rd power because it says cube roots, so I want x cubed equals 125. And I want to write it in that manner because, again, it says real cube roots. Again, it could be imaginary roots. I want to verify what I'm finding are only real roots. So then if I get this to equal 0, x cubed minus 125 equals 0, I get myself to a difference of cubes structure. X cubed minus 125. We already know x cubed is a perfect cube because we invented it. And 125 is 555, right? Makes 125, they're being subtracted. So x minus 5 is the first parentheses. And the second parentheses, if you recall, for difference of cubes, whatever this object is, we square it. Whatever these two things multiply together, x times 5 is 5x. Don't worry about signs in this scenario, just worry about the product without the sign. So 5x makes the middle, and whatever that number is squared makes the last. As far as signs are concerned, this sign's always the same sign as that, so minus, minus. This sign's always the opposite sign of that, so plus, and this last sign's always plus. So we create a difference of cubes, structure equal to 0, we factor the difference of cubes, and now we're looking to solve this, and what we're left with really is either factor 1 equals 0, x minus 5 equals 0, and then factor 2, if we take a look, it's a quadratic trinomial, lead coefficient of 1 on x squared, which means we could possibly factor this thing, so we try 1 times 25 makes 25, 1 plus 25 is 26, not 5. 5 times 5 makes 25, 5 plus 5 is 10, not 5. So it doesn't look like it factors easily. So when I'm looking at the second part, x squared plus 5x plus 25 equals 0, I'm looking to do the quadratic formula to find those answers because, again, it's not easily factored. In fact, I can't see how to factor that thing. So if I start off with the quadratic formula like I usually do, I'm going to start with the discriminant, b squared minus 4ac, because that's the hardest part of the formula. That's the part that messes people up. So I'd like to get it separate from the formula, figure out what it equals, and I can throw it in. B squared is going to be 5 squared, which is 25, minus 4 times a is 1, times c is 25. And notice if I multiply that out, it gets me 25, and there's only one minus sign there altogether, so it stays minus. 4 times 1 times 25 is 100, making negative 75. Now let me go back to the word real. Remember when we were discussing the nature of roots on a quadratic function, when we did b squared minus 4ac, if it came out to be a positive number, we get 2 real roots, right? 2 real answers. If it came out to equal 0, we get 1 real answer. If it came out negative, we get 0 real answers. In fact, we get 2 complex answers. So the fact that b squared minus 4ac came out negative means there's nothing real as an answer to that problem. So this gets me nothing. This problem here gets me x equals 5. So 5 is the only real root of 125. Cube root. Just to quick show you this, if I happen to finish this problem out, okay? So if I did x equals, the negative 75 goes in here, right? Minus b is the opposite of 5, which is negative 5. And 2a is 2 times 1, which is 2. Remember that when there's a minus sign in the square root, it becomes a plus with an I outside the square root. The other thing I notice is 75 is 5 times 5 times 3. That's the same as 75, so I can chop a 5 off and a couple of 5s, put a 5 out there. So I end up with x equals negative 5 plus or minus 5i times the square root of 3 over 2. Those are the other 2 roots. They're imaginary roots, they're complex roots, but again, they are roots. If I multiplied either one of those 2 things by themselves 3 times, I'll demonstrate on my calculator here. My calculator knows how to do imaginary numbers. So if I do -5 plus 5i times the square root of 3 got too many parentheses going on here. No, I don't. Divided by 2, all right, cubed. It equals 125. And again, all our work demonstrates that's what should have happened. This times this is the same as that, and these are the answers to that. If I had gone with the minus instead of the plus. So the two answers, first answer is plus 5i, the other answer is minus 5i, still 125. If I try 5 cubed, 125, all right? So again, that's all we're doing with the cube root, is we're finding what number times itself 3 times makes 125. This is one of them, those are the other two, but again, we only want the real ones, that's the only answer.